Good afternoon, grade 12 learners. My name is Mohapi, and today we are going to discuss the inverse functions. Grade 12 learners, our topic for today is the inverse functions. Remember grade 10, you studied the functions. Mainly you were focusing on the effect of Q on the graphs of the quadratic, exponential, and hyperbola, including the straight line. In grade 11, you studied the very same functions, but then you introduced a Q. A Q was introduced to you, and Q, the role of Q is to determine horizontal shifting to the left or shifting to the right. Thank you. So for today, we're going to study the inverse functions. Without any waste of time, let's get into the matter. What is expected from learners? From the policy document, it is clear that learners are expected to know the definition of a function. As a grade 12 learner, you must know what a function is. You must also understand the concept of inverse function and how domain of a function need to be restricted in order for the inverse to be a function. Maybe I need to read this one again. Understand how the inverse of a function, how the concept of inverse function, and understand how the domain of a function needs to be restricted in order for the inverse to be a function. Know what a function is, know how to restrict the domain of a function so that the inverse could also be a function, because not every inverse is a function. As a grade 12 learner, you are expected to determine the equations as well as the sketch the graphs of the inverses. Y is equal to ax plus q is a linear function. Y is equal to ax squared, parabola. The inverse of parabola, we need to know. Y is equal to b exponent x is an exponential. And what is important is that the inverse of the exponential, we call it the log. The inverse of an exponential is called a log. As a grade 12 learner, as you are studying these inverse functions, you focus on the characteristics of the functions. Check the domain, check the range, the turning points, minima and maxima, asymptotes, both vertical and horizontal. Remember, some of our functions have vertical and horizontal asymptote. So those are the concepts that you should focus on. Remember, if we talk of the domain, the weighted domain, we don't have to be scared. The weighted domain is nothing else but the x values of the graph. The x values of the graph. What is the range? The weighted range refers to the y values of the graph. Here we talk of the turning points. Which function has got turning points? Quadratic function. Even a cubic function, it has got turning points. The maximum turning point is referred to as maxima, whereas the minimum turning point is referred to as the minima. Asymptotes. If I were to talk of the hyperbolic function, hyperbola, it has got both vertical and horizontal asymptote. But if you talk of the exponential graph only have the horizontal asymptote. Focus on those characteristics. Let's start with the definition of a function. What do we understand by the word function? A function, f, is defined as a relationship between x and y values. Relationship between x and y values, where each x value maps to one y value. Hala, fantastic. A definition of a function is defined as a relationship between x and y, where each x value maps to one y value. That's why in brackets I have written, in other words, for an equation to be called a function, there can be only one y value for a particular x value. We have two types of functions, one-to-one and many-to-one. What is the difference? In a one-to-one function, that is where one y value associated or maps with one x value. Many-to-one, one x value can be associated with more than one y values. Do not swap them around. We said a function cannot have more than y values to each x value. It cannot. So there must be one x value, but that one x value be associated with more than one x values. Then we call it many to one. Remember, if a graph is not a function, it is then called, or it is then known as the relation. How do we determine the inverse? It's a $1 million question. In order to determine, in order to determine the inverse of a graph, we swap x and y, and then make y the subject of the formula. I need to highlight this one. Very much important. Maybe I need to highlight this one. And say, take note. In order to determine the inverse of a graph, x and y values must be swapped. And then you make y the subject of the formula. Which functions are we going to determine the inverses of? Remember, I showed them earlier here. Determine it's y equals to ax plus q, it's a linear. Y equals to ax squared is a parabola. Y equals to b exponent is an exponential. These are the graphs of which we have to study the inverses. So how do we determine the inverse? In all the three that I've indicated, the three functions, in order to determine the inverse of a graph, x and y values must be swapped. And after swapping them, you make y the subject of the formula. Grade 12 learners, you must have heard me very well. You must make y the subject of, you start first by swapping, and then you make y the subject of the formula. How do we denote the inverse? General expression for the inverse of the function f at x is given in this form. This is the inverse here. You see it has got the exponent -1, f exponent -1. That -1 indicates it's a notation for the inverse. Sometimes if you could talk of graph of g, then it will be g exponents -1. G exponent -1 will then represent the inverse of g. If you have h exponent -1, that will represent the inverse of the graph of h. If you've got the k exponent -1, then it means it represents the inverse of k at x, and so on and so on. The notation can only be used to represent the inverse of one-to-one relation. Every time when you deal with the inverse functions, it is important to notice that what exactly is happening between the domain and the range. Check as you are going to do some activities. Check domain, check x. Go back to the original function. Check the domain and the range of the function. Draw the inverse. Check the domain and the range of the function. And then you compare the two. In short, I would say the domain for the function becomes the range for the inverse. Take note of that. Because remember, the key in function is that x and y values are swapped. So if they are swapped, the domain of the function becomes the range of the inverse, and vice versa. More often we have a quadratic function, y equals to ax squared. Then we can be required, if got y equals to ax squared, it's a quadratic function, and the inverse thereof will not be a function. So the question is, how can we restrict the domain, the x values of the original function, so that the inverse should also be a function? Very much important. And we'll do an activity relating to that, to the restriction of the domain. Take note, a restriction in the domain of the original function corresponds to a restriction in the range of the inverse. Very much important. Take note of that. Thank you. Without any use of time, let's start with the logarithms. Let's start with the logarithms. What is a logarithm? Definition is given. A logarithm is a way of writing an exponential equation with the exponent as the subject of the formula. Let me repeat that. What is a logarithm? It's a way of writing exponential equation If you have an exponential equation and then you make the exponent the subject to the formula, then you're talking of the logarithms. In the equation, for example, x is equals to b exponent y. B must be greater than 0 and b not equals to 1. B in this case is referred to as the base and y as the exponent. Check here. This is b. This b here is the base. The y there is the exponent. Converting from exponential to log form, it is as follows. This is the definition of logarithms. Grade 12, grasp this one. Because without this one, you'll not get the inverse of exponents correctly. If x is equals to b exponent y, then it means y will be equals to the log of x base b. Remember the restriction. Every time for this to be applicable, for this rule to hold, for this definition to exist, b must be greater than 0, b must not be equals to 1, and x must always be greater than 0. Greater than 0 and here x must always be greater than 0. If x is less than 0, it becomes undefined. You have a function, log in your calculator, you punch in the log of a negative number, you'll see it will be undefined. If the base is not indicated, especially when you write the log and the base is not indicated, then you have to assume that it is base 10. The log function is the inverse of the exponential graph. I will highlight it. The log function is the inverse of the exponential graph. The logarithmic function is the inverse of the exponential graph. In order to determine the equation of the inverse of exponential function, you use the definition of the log. Because remember, to determine the equation of the inverse, x and y values must be swapped. And then after swapping them, you make y the subject of the formula. So remember, here's the definition. This is key. This definition is very much important. Here it is. This definition is very much important because look at y. Y here is an exponent. So how would we make y the subject of the formula? Introduction of log. Because it is an exponent. Introduction of log. Definition of logarithms. Perfect. So you need to know x is equals to b exponent y. It's an exponential equation. Y is equals to the log of x base b. It's a log equation. So be able to convert from log to exponential and from exponential to log. Grade 12 teachers, this is the basic, the most critical step. This is the critical definition regarding the inverse functions. So it is important for our learners to master the skill. Give them as many activities as possible where they convert or they change exponential equation to log and vice versa. Give as many activities as possible until each and every learner in your class teacher, until each and every learner is able to convert. Thank you. Let me do some few activities. Let me do some few activities that relate to the log functions. Fine. Let's check what we have here. Given the graph of g at x equals to log x base 1 over 3. It's a log. It's given. It is given. Maybe before I go to these logs, I can take you through some notes regarding inverse functions. Check this. Inverse functions. Let's check this one. Thank you. Here we have the quadratic function. And the quadratic function is given by f at x equals to x squared. Here it is. You see the parabola facing upwards. F at x is equals to x squared. The parabola facing upwards. Then a line is drawn. That line is called y is equals to x. Here is the line. And then after drawing the line y is equals to x, you reflect this quadratic function along the line y is equals to x. Let me repeat the statement. You reflect the line, the graph y is equal to x squared along the line y is equal to x squared. If you reflect a graph along y is equal to x, basically you are talking about the inverse. Reflection of a graph along y is equal to x is referred to as the inverse. To draw the graph, we use the table method. Y is equal to x squared. Here it is, -1 mapped with 1, 0 and 0, 1 and 1. Then it's a freehand diagram, it's a quadratic function, it's a parabola. You move your hand freely to join the points. Now you come to the graph of, you swap x and y. X is equal to y squared. You do the same. These are the points. And when you plot, you will end up with a diagram like this. This is the inverse. Inverse, facing putting the x-axis between the graph, inside the graph. Whereas the graph, the function, quadratic function, is facing upwards. The inverse facing to the right. Grade 12, no, understand that. If the function is facing upwards, its inverse will be facing to the right. In short, x values is facing upward, the y values are positive, therefore the inverse, the x value should be positive. If the graph was also minus x squared, it was going to be a quadratic function facing downwards. And then the inverse will then be facing to the left. I hope you understand what I mean. Go through some activities, some textbooks, check what I'm talking about. Remember, I said the graph that was given us y is equal to x squared. If you swap, x is equal to y squared. Now, if x is equal to y squared, we need to make y the subject of the formula. X is equal to, here it is, y squared is equal to x. So we need to get rid of the square root. How do we eliminate a square? We eliminate a square by introducing the square root, radical sign. Therefore, y is equal to plus or minus square root of x. This provided that x is greater or equal to 0. Think of we call this the restriction. X greater or equal to 0. It's a restriction. Why? Why do we have that restriction? It's a simple logic explanation. We have the restriction because if x can be less than 0, we're going to have the square root of a negative number. And we know that the square root of a negative number is undefined. So for this to be defined to exist, x must be greater or equals to 0. Thank you very much. The graph of y equals to the square root of x is not a function. It will not be, just like the graph of, remember, when I go back to the graph, this is the graph. It is not a function. How do you test whether the graph is a function or not? The most common method is what we call the vertical line test. Move or draw a vertical line. If the vertical line cuts the graph twice or more than once, in short, then it means the graph is not a function. But if it cuts it once, then it becomes a function. A vertical line test is a method that we use to establish whether a graph that is drawn is a function or not. Now, let's see how can we restrict the domain of the function so that the inverse becomes a function. In terms of parabola, there are two ways. You see, y is equal to f at x equals x squared. It faces upwards, but now we restrict to say x must be greater than 0. Now you focus where x is greater than 0. This one does not exist because on this side, x is less than 0. So we focus where x is greater than 0. How will the inverse look? This is how the inverse will look. This is how the inverse will look. And if you draw any vertical line, it will only cast this graph once. So it means we have restricted the domain of the function f. After restricting the domain of the function f, in the inverse of the graph f, the inverse of f also becomes a function. If the domain was not restricted, the inverse was not going to be a function because a vertical line test will cut it twice. there are two ways of restricting the domain. In the second one, we can say x must be less or equal to 0. How do we restrict the domain? In terms of a quadratic function, x greater than is 0, greater or equal to 0, number 1. Number 2, x less or equals to 0. So if x is less or equals to 0, this is how the graph will look like. Because x must be less than 0 from the y-axis to the left. Here it is, x squared. The inverse, here is the inverse. Thank you very much. And now you can tell the inverse will definitely be a function. Why do you say it will be a function? Because one x value will be associated or will map with one y value. It's a one-to-one relation. And this was y squared to the square root x squared. The inverse was y squared to the square root of x squared. Here, y squared minus the square root of x. I'm sorry, the inverse here was written is y squared to the square root of x. Ignore that exponent is a mistake. So y squared to the square root of x. This one is y squared minus the square root of x. In a quadratic function, you can restrict the domain in two different ways. X greater or equal to 0, x less or equal to 0. Which domain do we restrict? You restrict the domain of the function to ensure that the inverse is also a function. Because in this case, parabola, the quadratic function, is a function, but the inverse thereof is not a function. So we want that inverse to be the function. Hence, we restrict the domain of the function, the original function. We restrict the domain of the original function so that the inverse could also be a function. Thank you very much. Let's carry on. That was a bit on quadratic. Check exponential. Table method used to sketch the graph. See, this is the graph. Y is equal to 2 exponent x. Y is equal to 2 exponent x. If you reflect this graph, y is equal to 2 exponent x, along the line y is equal to x, this is the graph that is formed. This is the reflection. And the reflection will be x is equal to 2 exponent y. Let me repeat that statement. I said it once, I'm saying it again. If you reflect a graph over the line y is equal to x, basically you are talking about the inverse of that graph. How do we denote an inverse? You'll see the exponent will be negative. One of the previous papers, I remember there was a question whereby learners were given f of x equals to 2 exponent x. Then the question read, sketch the graph of reflection of f over the line y is equal to x. Learners could not respond to it. They are used to sketch the inverse. But I'm saying, as a learner, you must know, once we talk of the reflection over the line y is equal to x, we are basically referring to the inverse. Because what is the inverse? Inverse is the reflection of a function over the line y is equal to x. So whether the question wants you to draw the graph of the reflection of a graph over the line y is equal to x, or it requires you to draw the inverse, same thing. Please take note of that. So you see, check the base here, it was 2 greater than 1. The base here is greater than 1. So if with regard to the exponential, if b is greater than here, b, the base is greater than 1, we have an increasing function. As you move from left to right, the y values increases. So if the function, the exponential increases, its inverse will also increase. If the function decreases, its inverse will also decrease. Thank you. So this is y is equal to 2 exponent x, line y is equal to x. You reflect this line, this graph, y is equal to 2 exponent x, along the line y is equal to x. Then you form x is equal to 2 exponent y. Here it is. Here it is. And this x is equal to 2 exponent y. X and y are swapped. Remember, how do we determine the equation of the inverse? For you to be able to determine the equation of the inverse, x and y must be swapped, and then you make y the subject of the formula. If you make y the subject of the formula here, you'll end up with a y is equals to the log of x base 2, definition of logarithms. Go back to the definition of logarithms. That's why here it's clear. If x equals to 2 exponent y, then it's clear from the definition of logarithm that log x base 2 will then be equals to y. In other words, we can write the inverse of the function f at x equals 2 exponent x as, check the inverse, f exponent negative 1. That is the notation we use for the inverse. You have f at x, 2 exponent x. Therefore, the inverse will be f exponent negative 1, like it is clearly indicated here. This is just a general rule that we use to convert exponential to log and vice versa. This one, inside this square. We call this inverse of exponential function a logarithmic graph. In short, we just say a log graph. Log, check here, log is just an abbreviation of logarithm. So the inverse of the exponential function constitute log graph. I hope this example is clear. And in this case, if you can check, the function was increasing, even the inverse was also increasing. Grade 12 learners, f is increasing, function is increasing, even the inverse is increasing. Let's go to a decreasing function. Thank you. When do we have a decreasing function? Check the base here. The base is greater than 0, less than 1. The moment base is between 0 and 1, then it will have a decreasing function. And if it's a decreasing function, even its inverse will also be decreasing. The important characteristics of an exponential graph is the y-intercept. Every time x is 0, y is 1. Even the previous example. X-intercept. The y-intercept. X is 0, y is 1. Check the x-intercept here. 1, 0. They have swapped. This was the y-intercept, 0, 1. X-intercept, 1, 0. That's the inverse. X and y values are swapped. Even with this one, the decreasing one, y-intercept is 0, 1. X-intercept, 1, 0. See? Swapped. This is G, a decreasing function. The inverse, here is the inverse, a decreasing function. What is the inverse? The reflection of the function G with respect to the line y is equals to x. Grade 12, you must know the basic shapes by heart now. You need to know, once it is decreasing, we know a b will be between 0 and 1. Once it is increasing, b is greater than 1. Through practice, this will become easy. I wanted to take you through this so that you become aware. Brief summary of what I've just said. Summary of exponential and log graph. Here they are. We have increasing when a is greater than 0. A here is the base. When the base is greater than 0. It's a decreasing function, this one. On this side, this one is decreasing. When is the function decreasing? When base is greater than 0 but less than 1. In simpler terms, if base is between 0 and 1, then once the base is between 0 and 1, we have a decreasing function. Thank you. There we are. You can do some few activities. An example here. Here it is. Function f at x is equal to log x base a passes through the point 4 and negative 2. The first question, determine the value of a and hence the equation of f. All it states that x is 4, y is negative 2. You go to this function. F at x equals y is equals to log x base 2. You substitute y by negative 2. You substitute x by 4. It was log x base a. Now I've got log 4 base a because the value of x is 1, the value of y is 2. You substituted. From there you change from log form to exponential form. Teachers, I said, and I'm going to say it again, every learner in class must know how to convert exponential to log and log to exponential. Give them as many activities as it takes so that they must master the skill. Learners must master that skill. So if you have mastered the skill and you have -2 is equal to the log of 4 base a, it's easy to write this equation in exponential form. A exponent -2 equals to 4, and we know applying the laws of exponents, a exponent -2 is the same as 1 over a squared. Multiplying by LCD, 1 is equals to 4a squared, therefore a squared is equals to 1 over 4. Remember the question, we want to determine the value of a. Determine the square root, a is equals to 1 over 2. You ask yourself a question, why do we choose 1 over 2 and not negative 1 over 2? Because if you have a squared is equals to 1 over 4, the solution is supposed to be a is equals to plus or minus half. A should be half and a should be negative half. Check. It's a base here. And for a log to exist, base must be greater than 0. Hence, a must be greater than 0. Hence, a is half. Therefore, the equation becomes f at x equals to log x base half. Write down the equation B. Write down the equation of the inverse of f. Write down the equation for the inverse of f. This is the equation. F at x equals to log x base half. This is the function that is given. So f at x is nothing else but y. Here it is y is equals to log x base half is a function. For it, if you want to determine the inverse, swap x and y. It was y here, now we've written x. It was x there, now we have written y. X and y have been swapped. And then you make y the subject of the formula. Once you make y the subject of the formula, it means you'll have to convert from log to exponential. Grade 12 learners, we need to state facts as they are. In mathematics, as a grade 12 learner, you must know. It must be an easy process of converting log to exponential and vice versa. Without that skill, there's no way that you're going to cope with inverse of exponents. There's absolutely no way. It's a critical skill that you must have. You need not to beat about the bush. This is a must. For a learner to be able to get marks in these questions, master the skill, the definition of log, conversion from log to exponential and vice versa. Therefore, this is the equation of the inverse. Fantastic. Now, we can go back to the activities. Let's do some few activities there. Let's do some few activities. Let me make it smaller so that at least you can also be able to see the questions. Given the graph of g at x equals to log x base 1 over 3. That is the graph that is given. That is the graph that is given. A is the x-intercept of J. Here is A. Already, grade 12 learner, you must not be able to tell the coordinates of A. You must be able to write, even before even looking at the questions, you must be able to determine the coordinates of A. A is the x-intercept. And you know for x-intercept, x will always be 1, y will be 0. P is a point on G. Here is that point P. It's this on G. G is log x base half. Let's answer the questions then. The first question, there are 3 questions basically. Write down the coordinates of A. The second one, sketch the graph of inverse indicating intercept with the axis and 1 point. Sketch the inverse indicating an x-intercept with 1 point. Let's see how we will draw that one. Let's draw that one. Pardon me, a minute. Let's do it here. Good. This is what we are having. I'll try and work it out from here. Here is the question. Let's read it. Given g at x equals log x base 1 over 3. A, here is A. It's x-intercept. We know once A is an x-intercept, it means x must be 1, y must be 0. It's either you know by heart or even by calculations you can still know it. Because the graph that is given is g at x, which is equals to the log x base 1 over 3. So this is x-intercept. For x-intercept, y is 0. So you write 0 here. 0 will be equals to the log of x base 1 over 3. How do we solve that one? We need to convert from log form to exponential. Therefore, x will then be equal to, this is the base, 1 over 3 exponent 0. And we know according to exponential laws, any number to power exponent 0 is 1. Hence we say x is 1, y is 0. This is the first question. Write down the coordinates of A. The question clearly says write down. You don't even have to do the calculations, because that is something that you should be knowing. So the coordinates here, x is 1, y is 0. The next question. Sketch the graph of the inverse, indicating intercept with the axis and 1 point on the graph. Here is the graph. Look at the graph. This is a decreasing function. And if it's decreasing, even the inverse will also be decreasing. Go back to the notes that we discussed earlier. And I did indicate if f is exponential and log, the relationship between exponential and log. If the function is increasing, even the inverse will also increase. If the function is decreasing, even the inverse thereof will also be decreasing. How would you draw the inverse? According to the given restriction, I will just draw it here. Think you've got a Cartesian plane, the y-axis, the x-axis. Now, it is y-intercept is 0, so we will have something like this. Thank you. But now we have the y-intercept here. Y-intercept, x is 0, y is 1. This is the inverse. And the question says, sketch the graph of the inverse, indicating intercept with the axis. Here is the y-intercept. And 1 point on the graph of any point on this graph. Any point on this graph. Remember, this is the graph of y. This is the graph of y is equals to, let's check the base, 1 over 3. 1 over 3 exponent x. Any point, indicate any point except the x-intercept. Because here, the graph, the question wants us to sketch the graph of inverse, indicating intercept with the axis. Here is the intercept. There will be no intercept with the x-axis, because the x-axis will now be serving as the asymptotes. And one other point on the graph, to be easy, any point that will be easy to say what will happen if x is 1. If you substitute x by 1, y will be 1 over 3. So x can be 1 here, then y will be 1 over 3 there. So this is the point. Indicate any point. Let's call it point A. X is 1, y is 1 over 3. Any point is fine. So this means we have answered 8.2. Check 8.3. Write down the domain of the inverse. Here, what is a domain? Domain refers to the x values of the graph. Look at this. This arrow here indicates the graph continues indefinitely. Even here, the arrow here indicates the graph continues indefinitely. How would you write down the domain of the inverse? This is the inverse. So domain is nothing else. To answer 8.3, x is an element of real numbers. X is an element of real numbers. That will be the domain. On the same note, I can take you to a task. What is the range of this graph? You look at this very same graph, the inverse, the very same inverse. This question here wanted the domain. Now I'm saying determine the range here. The range of this graph is nothing else. Range here is nothing else but y greater than 0. That was the first activity that I wanted to discuss with you. And it was on exponents and log. hope we are fine. I hope that we have seen how we solved this one. Let me take you through another example. Let me take you through another activity. Good. This is the activity that we just did. A question, clearly, because on the paper here I was writing on, everything became dirty and a bit slovenly. But this was the question, and these were the instructions. So you can copy it, do it nicely, relaxed. You pause, you play, you answer the question, you go back to how I solve it, then you'll have a better understanding, because at the moment I'm working against time, but if you are alone, you'll have your own time to interpret everything slowly, and that way you will be able to understand what you're doing. Fine. This was the log and the exponents. Check this out. Here is another one. Still on log and exponents. Sketched below are the graphs of g at x or k exponent x, where k is greater than 0 and y is equal to the inverse. While this is drawn there, we have two graphs, exponential and its inverse. Exponential and its inverse. You are also given a point 2 and 36. Without even going through anywhere, you can tell that the first question will say, determine the value of k. Determine the value of k. The very first question, determine the value of k. Which point is given? We've got 2 and 36. Let me write them down. This point is given. 2 and 36 is given. It's a point. And what we have the function g at x, which is equal to k exponent x. Now the first question, 5.1, determine the value of k. 5.1.2, determine the equation of the inverse. Year in, year out, these are the basic questions that we should answer. Check. Here is the point that is given. Remember, it was 5.1.1, 5.1.1. The question wanted us to determine the value of k. Now we come here, we substitute y by 36. X you substitute by 2, which is equals to k exponent 2. Remember the restriction, k must be greater than 1. So we solve, can say 6 squared is equals to k exponent 2, therefore k is equals to 6. Or you can determine the square root both sides. As you determine the square roots, do not write plus or minus 6. Do not write plus or minus 6. Do not write k is equals to plus or minus 6. Don't. Because the value of k here there must always be greater than 1. K must be greater than 0. So k will then be equals to 6. Do you still remember the question, determine the value of k? We have answered the question. The next question was determine the inverse. It was 5.1.2. If this is the value of k, we can write down the equation. It means g at x. G at x is given as 6 exponent x. That is the equation of g. In 5.1.2, the question wants us to determine the equation of the inverse. Inverse is written like this. We want the equation of the inverse of that graph. So if you want to determine the equation of the inverse, you swap. This is y, this is x. Now you say x is equals to 6 exponent y. I have swapped x and y. Don't get confused. This thing, g at x, is basically y. Do not get confused. Sometimes you might have h at x. This is basically y. Do not get confused. First, we use h, g, k, and so forth just to differentiate between different functions. So, but basically, this is the y value. So we swap. Instead of y here, we write x. Instead of x there, we write y. Now, after swapping x and y, what do we do? You make y the subject of the formula. You make y the subject of the formula. So if you make y the subject of the formula here, I think y will then be equals to the log of x base 6. That is the inverse. Y is equals to the log of x base 6. 5.1.2. The question wanted us to write the inverse in the form y is equals to. Here is the question. Here is the question. Thank you. Sorry. Go back to the question. There is the question. Give the equation of the inverse in the form y is equals to. 5.1.2. For which values of x is the inverse greater than 0? Simple. This g exponent is a y value for the inverse. And y value, where will y be greater than 0? Look at the graph. This is the graph. Y is less than 0 here. From this point, what is the x-intercept here? You need to work out the x-intercept. You need to work out the x-intercept. And the x-intercept there is x is 1 and 0. So to answer this question, the solution will then be this is our solution, 5.1.3. 5.1.3. It means for us to take those values of x where the values of x where the inverse is less or equal to 0. X must be less or equal to 0, less than 1, but greater than 0. That is the solution for 5.1.3. That is the solution for 5.1.3. X cannot be 0. X must always be greater than 0. Here is the function. X must, for this to exist, x must be greater than 0. The x-intercept here of this graph, x-intercept. Remember, for x-intercept, y will be 0. If we work out the value of x, x will be 1. So x must be greater than 0, but less or equals to 1. Check 5.1.4, the question. 5.1.4, the question. There it is. Write down the domain of that graph for 1 mark. What is domain? Domain is nothing else but the x values. Domain is nothing else but the x values. For the graph function to be defined, what must be the domain? Let's check. 5.1.4. 5.1.4. We need to write down the domain of h, and it's given that h at x is equals to the inverse x minus 3. That is what is given. Let's write it down. Remember, our inverse is here. It means h at x is equals to, our inverse is the log of, instead of x here, we write x minus 3 base 6. So for this to be defined, the domain, it means this number here must be greater than 0. Therefore, x minus 3 must be greater. The domain, the x must be greater than 0. Therefore, x is greater than 3. This is the domain. X must be greater than 3. Thank you very much. When you have time, you go through that on your own. When you do have time, you'll go through that on your own. Let me take you through another activity there. I did not even do all the activities. Time is against me. This is the parabola and the straight line. The graph of f at x was minus x squared and g at x was minus 2x minus 3 are sketched. The two graphs are sketched there. A and B are the points of intersection of f and g. A and B are the points of intersection of f and g. There are the graphs. We are given the two graphs. The first question, 3.1, determine the coordinates of A and B. determine the coordinates of A and B. The second question, determine the equation of the inverse of G in the form y is equals to. I'll try and work it out from here so that we do not get lost. Thank you. Running short of papers, minute. There we are. There we are. The first question, determine the coordinates of A and B. What is A and B? Point of intersection of the two graphs. I will write down the equation of the graphs. I've got f at x. I've got f at x, which is equals to minus x squared. And we also have g at x, which is equals to minus 2x, minus 2x, minus 3. Let me answer the first two questions. Determine the coordinates of A and B. And then the second one, we need to determine the equation of the inverse of G, the equation of the inverse of G. That will be the second questions. Let's start with the first one. Here we are. These are the two functions. Now we have to start with the solution of the first one. The point of intersection, the coordinates of A and B. Now, you know, you equate the two graphs. This is basic knowledge that you should know. For point of intersection, you equate the two graphs. Now it's a quadratic equation. Let's write the equation in the standard form. 0 transpose, it's got x squared minus 2x minus 3. Now you factorize x minus 3, x plus 1. Therefore, x will be equals to 3, or x will be equals to negative 1. Now we must work out the corresponding y value. If x is 3 here, what will be the value of y? You take 3, you substitute here. Minus 2 multiplied by 3 give you negative 6. Minus 3 will give you negative 9. Let's check here. If x is equals to negative 1, what will be the corresponding value of y? If x is negative 1, you substitute x by negative 1 here. Minus 2 multiplied by negative 1, positive 2. Minus 3 is going to be negative 1. Then we have 2 points. 1 point, x is 3, y is negative 9. Second point, x is negative 1, y is negative 1. Now we need to establish which point is A and which point is B. Go back to the graph. Check A. We can see where A is. It means at point A, this one will definitely be point A, and this one will definitely be point B. The question answered. Let's determine the equation 3.2 and 3.3. 3.2 and 3.3. Let's answer both. In 3.2, determine the equation of the G, the inverse of G. In 3.3, you determine the equation of the inverse of F. Let's work them out. 3.2, the inverse of G. Remember, G at x is given as minus 2x minus 3. I said, once you see G at x, it's nothing else but y. Function y expressed in terms of x. So what do we do? For the inverse, swap x and y. G inverse. You see, x is equal to minus 2y minus 3. Nothing else happened. All I did, instead of y here, I wrote x. Instead of x here, I wrote y. That's how we determine the equation of the inverse. From there, you make y the subject of the formula. It's minus 2y, I transpose to the left. Minus 2y, if you transpose to the left, it becomes positive 2y. I've got x here. This x, I transpose to the right, it becomes negative x. Minus 3 is already on the right. Now I have to divide both sides by 2. I've got to divide throughout by 2. Therefore, if you divide by 2, y will be equal to negative 1 over 2x minus 3 over 2. This will be the inverse of G. This is the inverse of G. Y is equal to negative half x minus 3 over 2. Do you still remember the question on 3.3? In 3.3, we were asked to determine the inverse of f. Where is f? F was given as minus x squared. F was given as minus x squared. How do we determine the equation of the inverse of f? Is 3.3. It's 3.3. Now, don't worry. Once you determine the inverse, swap x and y. You see it's y here. X is equals to minus y squared. But let's indicate now we are talking about the inverse of f. That is the inverse of f. Now we have to make y the subject of the formula. You see, we've got an exponent here. Oh, let's eliminate this sign first. It's a negative. Divide both sides by negative. You have negative x, which is equals to y squared. Now, how do you eliminate a square here? You introduce a square root. Therefore, y will be equals to plus or minus the square root of negative x. Plus or minus the square root of negative x. And for this to exist, x must be less than 0. That is a given restriction. X must be less than 0. Because if x is positive here, we'll have a square root of negative number, which is undefined. So it's just a restriction. This is the equation of the inverse of f, 3.3. Let's check the question 3.4 going onwards. But now we have written down the inverse of g, the inverse of g here, and here this is the inverse of f. This is the inverse of f, f negative now. Here it is, the inverse of f. Let's carry on and look at the next questions. 3.4. Give a reason why the inverse of x, which is y squared plus square root of x, is not a function. Why? Give a reason. Why is that this is not a function? Give a reason why. The first part of the question. The first part of the question. Give a reason why the inverse, y squared plus or minus square root of x, is not a function. It will not be a function because one x value will be associated, or one x value will map with more than one y values. One x value mapped with more than one y values. That is the reason. Place a restriction on the domain of H so that, let's place the question is place the restriction on the domain of H, the function, so that the inverse should also be a function. We discussed it. We discussed it earlier. And we said x must be greater or equal to 0, or x must be less or equals to 0. All I'm doing at the moment is to expose you to more activities. I'm just exposing you to different activities. Through practice, one will get better and better. So, grade 12 learners, in mathematics, you always say practice makes perfect. So, there's only one way out. Let's keep practicing, practicing, practicing. Then we'll improve on our skills. I'm going to leave you with your homework. Time is against me. I'm going to leave you with another activity. Here is another activity. Check number 4. f at x equals 3 exponent negative x. Determine the equation of the inverse of the inverse. All you have to do is swap x and y. Simple, straightforward. Then sketch the graphs. Sketch the two graphs. What do we have? We have f at x. What is that? We are given f at x, which is equals to 3 exponent negative x. Determine the equation of the inverse, number 1. Number 2, sketch the two graphs. Check. This is the graph. To make it easier, this can also be written as f at x equals to 3 exponent negative 1 This is negative 1. It's 1 over 3 exponent x. And we know it will be a decreasing function. It is a decreasing function. The first question, remember, it was determine the equation of the inverse. That was 4.1. The inverse here, instead of y, we write x. 1 over 3. Instead of x, we write y. Now make y the substitute formula. Therefore, y will be equals to the log of x base is 1 over 3. That is the inverse. I still repeat, definition of logarithms is key. 4.2. The question wanted us to sketch this graph and its inverse. We need to sketch the two, the graph and its inverse. 1 over 3 exponent x is a decreasing function. Here is the graph. Roughly something like that. What do we indicate? The y-intercept. We've got the y-axis and the x-axis. X here, 0, y is 1. That is the graph. This is the graph of f. That is the graph of f. The inverse, look at the inverse. Inverse will also be decreasing. Thank you. Intercept, x-intercept 1, y 0. This is the graph of the inverse. Question answered. Perfectly so for that matter. Full marks. Full marks. I think I've come to the end of the session. I can only say you can start doing whatever, answering other questions. But because of time, let me leave you with this activity then. I'll leave you that activity. Practice it on your own. You've got the quadratic function. You've got the exponential graph drawn on the same set of axes. Answer those questions. Where you encounter problems, feel free to consult your teachers. Grade 12 learners, I don't know how many times must I say this. Maths is a subject that requires practice. If you do not practice, there is no way you can do well in mathematics. You need to be patient, and you need to ask for assistance. Go to your teachers, go to the fellow learners, whoever person that can assist you with mathematics, feel free to consult the person. Because through practice, you will get better, and this subject is key for your future. On that note, let me take the opportunity to thank you for watching this lesson on inverse functions. I hope you've enjoyed. I enjoyed. I believe that if you can keep watching and playing, pause, and all those things, you'll get better. You will get better and have a better understanding. This topic of the inverse functions is not really that difficult. Because inverse functions, it's all about swapping x and y and making y the substitute formula. Let me wish you all the best with your studies. I thank you for today.